Under your feet, all around you, are rocks and minerals. Many times in your life, you've probably picked up a rock and looked at it. You may have climbed over rocks and mountains and never given a single thought as to what they consist of or what they even are. Rocks and minerals don't just make up our planet, but many objects in the universe as well. But what are rocks and minerals, and what exactly are the differences between them? Learn more about rocks and minerals and exactly what they are on this episode of Everything Everywhere Daily.
This episode is brought to you by Google. The Google Cybersecurity Certificate provides the necessary skills to begin a career in cybersecurity. Visit safety.google/cyber workforce today.
This episode is sponsored by Curiosity Daily. Hey everyone, I wanted to tell you about Curiosity Daily, the award-winning podcast from Discovery, a podcast that covers the latest science and technology news from around the world. 3 times a week, the award-winning Curiosity Daily podcast will help you get smarter about the world around you. In less than 10 minutes, you'll get a unique mix of research-based life hacks, the latest science and technology news, and much more. Co-hosts Nate Bonham and Callie Gade will help you learn about your mind and body, outer space, the depths of the sea, and how history shaped the world into what it is today. Recent episodes have discussed how scientists are using AI to talk to animals, how researchers found a hidden chamber in the Great Pyramid of Giza, and how people with curly hair may actually have an evolutionary advantage. If you're a curious person, and let's face it, if you're listening to this podcast you are, then listen to Curiosity Daily wherever you listen to this show. Once again, Curiosity Daily. I might as well start out with the obvious question, a question that many of you may have never bothered to ask at any point in your life. What is a rock? We all know a rock when we see one, but what exactly is it? A rock is nothing more than an aggregation or an amalgamation of minerals. Well, okay, that then brings up the next question. What is a mineral? The standard definition of a mineral is that it is a naturally occurring solid that has a well-defined chemical composition and crystal structure. So, for example, glass is solid, but it's amorphous. It has no crystal structure, so glass is not a mineral. Liquid water has a definite chemical structure, but it's not a solid, so it is not a mineral. However, ice is a solid, and it does have a crystalline structure, and ice is technically a mineral. Actually, ice isn't just a mineral, it's 20 different minerals. At extreme pressures and temperatures, conditions under which we would never experience, ice can have different crystalline structures, making them different minerals. There are thousands of different minerals, each with its own chemical composition and crystalline structure. Depending on the source, there are somewhere between 5,663 and about 7,000 known minerals. There are new minerals, usually quite rare, being discovered on a regular basis. One of the most recent minerals was discovered in 2022, and it's called Elkin-stantonite. A small sample of it was discovered in a meteorite that landed in Somalia. However, these new novel minerals are usually extremely rare. Most of the minerals you can find on Earth are very common and abundant. Quartz is one of the most common minerals on the surface of the Earth. The chemical name is SiO2, meaning it consists of 1 silicon atom and 2 oxygen atoms, and it has a hexagonal crystalline structure. The crystal structure, just as much as the chemical composition, helps define a mineral. A great example are the minerals kyanite, andalusite, and sillimanite. All 3 of the minerals have the exact same chemical composition, Al2SiO5, or 2 aluminum, 1 silicon, and 5 oxygen. All 3 minerals look completely different from each other. So how is it that minerals with the same chemical composition can be so different? This is because when they were created at different pressures and temperatures. The different conditions resulted in different crystalline structures and hence seemingly totally different minerals. There are a set number of crystalline structures that can exist. They're defined by the angles and arrangements of the individual atoms in the crystal. They can be cubic, hexagonal, tetragonal, and some others that are beyond the scope of this episode, but I did have to learn them all in my mineralogy course. Some minerals are actually categories of minerals with a number of different elements that can comprise it. One of the most common mineral groups is known as feldspar. There are actually several different feldspars which have different combinations of elements. The general composition of feldspar is written as XZ4O8. The X can be potassium, calcium, or sodium, and the Z can be silicon or aluminum. The O is still oxygen. Each one of these combinations does have a different name, but they're all lumped together as feldspars. One of the things that geologists have to do in the field is identify minerals, and this is often much more difficult than it seems. For example, there are several black minerals, and you can't just tell what they are from the color alone. One test used to identify minerals is hardness. Minerals are ranked on a scale known as Mohs hardness scale. The scale is relative and not absolute, with different minerals at different points on the scale. The hardest mineral is diamond, which ranks a 10, and the softest is talc, which is a 1. Quartz is a 7 on the hardness scale, and the number 9 is an aluminum oxide known as corundum. In terms of absolute hardness, diamond is almost 4 times harder than corundum. Some minerals, when found in a very pure form, are considered gemstones. Ruby is a form of corundum, as is sapphire. Emeralds are a form of the mineral beryl. Opal is an example of a gemstone, which actually isn't technically a mineral. It's amorphous and doesn't have a crystalline structure. There are also very different minerals inside the Earth than what exist on the surface. Because of the massive differences in pressure and temperature, the most common minerals inside the Earth are usually never or seldom found on the surface. One common mineral category in the Earth's mantle is called perovskite, which is a family of minerals like feldspar. The virgin known as bridgmanite is believed to make up 38% of the Earth by volume, almost none of which is seen on the surface. I'll probably be talking more about minerals in future episodes, and this is a very large topic that mineralogists spend their entire careers on. But what you should take away is that a mineral is a solid chemical compound where the individual atoms are arranged in a crystal lattice structure. Rocks, then, are collections of minerals, and the study of rocks is known as petrology. Depending on the type of rock, you might be able to look at a rock and see the individual minerals which comprise it. A good example would be a granite countertop. The next time you're near one, if you take a close look, you'll be able to see individual minerals that are probably the size of one of your fingernails or smaller. Rocks are categorized into 3 different types: igneous, metamorphic, and sedimentary. Igneous rocks are rocks that were formed from liquid magma or lava. The term igneous comes from the Latin word for fire. There are 2 types of igneous rock that at first seem very different from each other. They are intrusive igneous rocks and extrusive igneous rocks. Intrusive igneous rocks are rocks like granite. They were formed when magma inside the Earth cooled. The reason why you can see individual minerals in a granite countertop is that the magma cooled very slowly because it never broke through the surface of the Earth. The slow cooling results in larger individual mineral grains to form. As I noted above when talking about minerals, how minerals form depends not only on chemistry, but also on the pressure and temperatures at which it was formed. Extrusive igneous rocks are those that make it to the surface. The most common type is known as basalt. Basalt is almost uniformly black. If you look closely at it, you probably won't find any individual grains of minerals. And it isn't because they aren't there, it's because the grains are so small. Lava that makes it to the surface cools quickly, which results in small grain size. When the Earth was formed, all rock was igneous rock. But if everything was igneous rock, how did other types of rock come to exist? Over time, rain and wind erode rock and break it down into smaller particles. These particles can accumulate over time and, via pressure, can become new rocks. These are called sedimentary rocks. The most well-known type of sedimentary rock is sandstone, which, as the name suggests, is primarily made out of sand. However, there are other types of sedimentary rock as well. Shale, chalk, chert, mudstone, siltstone, and coal are all sedimentary rocks. Another major type of sedimentary rock is limestone. Limestone forms when calcium carbonate precipitates out of the water and settles. This process of calcium carbonate precipitating out of the water is occurring today in the Caribbean Sea. Dolomite is a rock very similar to limestone. It's produced through a process of chemically altering limestone by adding magnesium. Dolomite looks very similar to limestone, and in the field, geologists will often test rock using dilute hydrochloric acid. If there's a strong reaction, then it's limestone, and if there's a weak reaction, it's dolomite. The final type of rock is metamorphic rock. This is the least common type of rock and one that it's possible you've never even encountered. Metamorphic rock is created when pre-existing rock is changed due to pressure and temperature. The starting rock could be sedimentary, igneous, or even other metamorphic rock. The rocks are subject to increased heat and pressure, and often fluids like water. These conditions will literally change the mineral composition of the rock, allowing the elements to reform into new different minerals. In the example I gave above, kyanite, andalusite, and sillimanite are all created through metamorphic processes. Which minerals appear can tell geologists what the pressure and temperatures were when the rock was first formed. Personally, I find metamorphic rocks the most interesting, even if you do have to go to your way to find them. I spent time in the Black Hills of South Dakota on a geology trip once, and there were tons of locations we visited that had some of the most fascinating mineral formations I've ever seen, and almost all of them were metamorphic rocks. This is not the end of the story of rocks. Just like with water, oxygen, and carbon dioxide, there is a rock cycle. Very slowly over geologic time periods, rocks can actually be recycled and renewed. Much of the rock cycle consists of things I've already described. Erosion and rising magma are two big parts of the cycle. The creation of metamorphic rock is also part of the cycle. However, during the metamorphic process, it's possible for temperatures and pressures to get so extreme that rocks once again melt, forming igneous rock. When rock erodes, no matter the type of rock, small particles such as sand and clay will often get washed down streams and rivers where it will be deposited into the sea. If you remember back to my episode on volcanoes, there are some tectonic plates known as subduction zones. This is where one tectonic plate is literally pulled under another. The plate that is subducted, while mostly consisting of basalt, will also have a layer of sediment consisting of eroded rock. That rock will eventually melt and then be returned to the surface through volcanic activity. This is brand new igneous rock that can then be weathered, eroded, starting the cycle again. If you find the subject of rocks and minerals boring, I suggest looking online at some of the great mineral collections that exist. There are minerals that are some of the most beautiful things that you will ever find in the natural world. Brilliant colors of almost every hue you can imagine. One of the best collections of minerals in the world can be found at the Smithsonian Museum of Natural History. They have over 350,000 mineral specimens and 10,000 gemstones. The original collection was gifted to the museum by Dr. James S. Douglas, who is a mining engineer who assembled most of his collection in the late 19th and early 20th centuries. And if you're ever in Washington, I highly recommend taking the time to visit. Fantastic mineral collections can be found at the Australian Museum in Sydney, the Museum of Natural History in New York, the Natural History Museum in London, and the Royal Ontario Museum in Toronto. But maybe the greatest collection in the world is actually at the Houston Museum of Natural Science. About 20 years ago, after spending time in the world of business, I went back to school to study geology. And one of the things I came away with was a deep appreciation of simple things like rocks and minerals. Rocks and the minerals that comprise them are the literal foundation of our world. Every rock tells a story about how it was made and where it came from. And it's something to think about the next time you pick up a random stone. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Peter Bennett and Cameron Kiefer. Today's review comes from listener In Engineering over on Apple Podcasts in the United States. They write, "Love it. I love science. This is the perfect podcast." Well, thanks, In Engineering. I love science too, as well as mathematics, geography, history, and of course, the Green Bay Packers. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.